Welcome to Enterprise Web Security. Today, we're diving deep into Google Cloud Secure Web Proxy, a revolutionary approach to web security that transforms how organizations protect their digital perimeter. This isn't your traditional hardware-based proxy that sits in a dusty server room requiring constant maintenance. Think of this service as having a team of Google's best security engineers working 24/7 to protect your organization's web traffic. Every single web request your users make flows through Google's global infrastructure, where machine learning models trained on billions of data points make split-second decisions about what's safe and what's dangerous. In 2024, web-based attacks account for over 75% of all security breaches. Traditional perimeter security assumes anything inside your network is trustworthy, a dangerous assumption in today's cloud-first world. This is exactly why we need a fundamentally different approach. What makes this particularly exciting is the zero configuration scalability. Google automatically provisions capacity based on your traffic patterns, handles software updates, and continuously improves threat detection using global intelligence. Your security team can focus on policy and response rather than infrastructure management. The cloud-native security revolution. Let me paint a picture of what traditional web security looks like versus this cloud-native approach. Most organizations today are running proxy appliances that were designed when YouTube didn't exist and social media meant email. These systems struggle with modern encrypted traffic, can't scale during events like Black Friday, and require specialized expertise to maintain. Google Cloud Secure Web Proxy represents a fundamental shift in thinking. Instead of trying to recreate Google's infrastructure in your data center, you're leveraging the same systems that protect Google's own traffic. The zero trust model means we never assume any request is safe just because it originated from inside your network. Organizations typically see 40 to 60% reduction in security incidents and 90% reduction in proxy-related operational overhead after migration. This isn't just about better security. It's about operational efficiency and allowing your team to focus on strategic security initiatives rather than keeping hardware running. The advanced threat detection isn't just signature-based blocking. Google's AI models analyze request patterns, destination reputation, content characteristics, and user behavior to identify threats that traditional systems miss. This includes zero-day attacks, advanced persistent threats, and sophisticated phishing campaigns. Comprehensive logging means every web transaction is recorded with full context, not just what was accessed, but who accessed it, when, from where, and what policies were applied. This creates an audit trail that security teams dream about for incident investigation and compliance reporting. Architectural deep dive. Understanding the architecture is crucial for successful implementation. The security gateway is where the magic happens. It's a horizontally scalable cluster of security processing nodes that Google automatically manages. Each node runs multiple security engines in parallel, including URL reputation checking, malware scanning, content analysis, and policy evaluation. The machine learning models are fascinating. Google trains these on petabytes of web traffic data, including known attacks, user behavior patterns, and content classification. The models update continuously, literally thousands of times per day, as new threats emerge. This isn't possible with traditional signature-based systems that might update once daily. The proxy engine handles the technical complexity of modern web traffic. It supports HTTP/2, WebSocket connections, and progressive web applications. SSL termination happens at Google's edge locations, meaning your users get the performance benefits of Google's global CDN while maintaining security inspection capabilities. The proxy engine maintains full session state, so applications that require persistent connections work seamlessly. This includes modern SaaS applications, streaming services, and collaborative tools that would break with traditional stateless proxy configurations. The policy engine is where your organization's security intelligence meets Google's global threat intelligence. You define rules based on your business requirements, such as user groups, time restrictions, application categories, and data sensitivity levels, and the engine applies these consistently across all traffic. Analytics and reporting provides visibility that most organizations have never had before. You can see traffic patterns by user, application, geographic location, and threat category. The dashboards help identify both security risks and productivity opportunities. For example, maybe you'll discover that 30% of your bandwidth is consumed by streaming video during business hours. Security Command Center Integration. Security Command Center integration elevates secure web proxy from an isolated security tool to part of a comprehensive security ecosystem. Think of SCC as your security mission control. It aggregates findings from dozens of security services across your Google Cloud environment and correlates them to provide actionable intelligence. When the web proxy detects a threat, say, a user trying to access a known command and control server, that finding immediately flows into SCC. But here's where it gets powerful. SCC can correlate this with other signals. Maybe the same user recently triggered unusual activity in cloud storage, or their account showed abnormal login patterns. Suddenly, you're not just dealing with a web security incident, you're investigating a potential account compromise. SCC can correlate web proxy findings with IAM anomalies, data access patterns, network traffic analysis, and even external threat intelligence feeds to provide comprehensive threat context. This intelligence fusion capability transforms isolated security events into comprehensive threat intelligence. The risk assessment capabilities use Google's threat intelligence combined with your organization's specific context. A request to a newly registered domain might be low risk for most organizations, but high risk if your company has recently been mentioned in threat intelligence reports. SCC understands these nuances and adjusts risk scoring accordingly. Compliance monitoring becomes automated rather than a quarterly scramble. SCC continuously tracks which security policies are being enforced, what traffic is being inspected, and whether your configuration meets various regulatory requirements. You get real-time compliance dashboards instead of expensive third-party audits to tell you whether you're meeting standards. The export capabilities mean your existing SIEM systems can consume this intelligence. Whether you're using Splunk, IBM QRadar, or Microsoft Sentinel, SCC can push security findings and context in formats your Security Operations Center already understands. Traffic Flow Deep Analysis. Let's trace a real user request through the system to understand exactly what happens. When Sarah from accounting clicks on a link in an email, her browser initiates an HTTP request. But before that request touches the internet, it is intercepted by our proxy service running on Google's Global Edge network. The first checkpoint is authentication and policy evaluation. The system identifies Sarah based on her network credentials or device certificate, looks up her group memberships, and checks what policies apply to her. Maybe accounting users have restricted access to social media during business hours, or elevated privileges for financial applications. Threat scanning happens in milliseconds using Google's Global Threat Intelligence database. The destination URI is checked against hundreds of threat feeds, including Google's own web crawling data, industry threat sharing platforms, and machine learning models that identify suspicious domain patterns. If the destination shows any indicators of compromise, the request is immediately blocked. This entire process adds less than 50 milliseconds of latency on average, and often improves performance through intelligent caching and content optimization. The parallel processing architecture ensures that security does not come at the cost of user experience. Content filtering considers not just the destination domain, but the specific URI path, query parameters, and even the referring page. A link to YouTube might be allowed for marketing users but blocked for production engineers. The categorization engine understands context. News sites are generally allowed, but specific sections about sensitive topics might be restricted. On the response side, data loss prevention scanning examines downloaded content for sensitive information. This is not just simple pattern matching. The DLP engine understands document structure, can detect obfuscated sensitive data, and recognizes when information might be exfiltrated through seemingly innocent channels like image metadata or encoded in URIs. Understanding system choreography. This sequence diagram reveals the sophisticated choreography between system components during request processing. Notice that unlike traditional proxy systems that process requests linearly, this architecture parallelizes security checks for optimal performance. The authentication and policy evaluation happens immediately, within the first few milliseconds of request receipt. This early gate ensures we don't waste computational resources on unauthorized requests. The system maintains a distributed cache of user credentials and policy states, so authentication decisions are blazingly fast. Threat intelligence queries happen in parallel with initial request validation. Google maintains multiple threat intelligence databases distributed globally, so the proxy can query the closest database cluster. This distributed architecture means threat intelligence lookups don't create a performance bottleneck even during traffic spikes. The system can make preliminary forwarding decisions while threat intelligence queries are still in flight, then apply enforcement actions if threats are detected, minimizing user-perceived latency. This predictive processing approach is only possible with Google's massive global infrastructure. When requests are blocked, immediate logging ensures full auditability. The system captures not just what was blocked, but the complete decision context, which policies applied, what threat intelligence was consulted, user context, and even network path information. This comprehensive logging is crucial for both security investigation and compliance reporting. For allowed requests, the response processing pipeline includes content scanning and DLP analysis. The system can inspect responses in real time, applying content-based policies and data protection rules. This bidirectional security model ensures threats can't sneak in through response channels or sensitive data can't leak out through legitimate business applications. Network integration strategy. This topology diagram shows how elegantly secure web proxy integrates into existing network architectures. The beauty lies in its non-disruptive implementation. You don't need to redesign your entire network or replace existing infrastructure. The proxy service sits logically between your users and the internet, but physically runs on Google's global edge network. Your users connect through existing VPN or SD-WAN infrastructure with zero client software requirements. This is crucial for organizations with bring-your-own-device policies or complex endpoint management challenges. Users experience transparent security. They don't know their traffic is being inspected and filtered unless they try to access something that is blocked. The integration with Google Cloud's operational services provides unprecedented visibility. Cloud logging captures every transaction with rich metadata. Cloud monitoring provides real-time performance and security metrics, and Security Command Center correlates web security events with other security data across your Google Cloud environment. Google's Edge network includes over 140 points of presence worldwide, meaning your users get security processing with minimal latency regardless of their geographic location. This global distribution is something that would cost millions of dollars to replicate with traditional infrastructure. The proxy service can forward traffic to any internet destination, traditional web servers, modern CDN services, and cloud-native SaaS applications. The global nature of Google's network means your users benefit from optimized routing to these destinations, often resulting in better performance than direct internet access. Network traffic flows are optimized automatically. Google's systems understand global internet topology and can route traffic through the most efficient paths, taking into account not just network latency but also security processing capabilities at different edge locations. Foundation requirements deep dive. Before we touch a single command, let's ensure your environment is properly prepared. I've seen too many implementations fail because of overlooked prerequisites, and these failures often happen weeks into the project when momentum is high and stakeholder expectations are set. Google Cloud Platform billing configuration is more nuanced than it appears. Secure web proxy can generate significant costs, especially during initial deployment when traffic patterns are being established and policies are being tuned. Ensure you have appropriate spending alerts configured and understand the pricing model. You pay for processed traffic volume, not just gateway instances. The IAM permissions extend beyond just security admin and network admin roles. You'll need service usage admin to enable APIs, potentially organization policy admin if you're implementing organization-wide policies, and logging admin for comprehensive audit trail configuration. Don't forget that service accounts will need appropriate permissions for automated operations. Network Security API has quota limits that vary by region. Check your quotas before starting implementation, especially if you're planning large-scale deployment or have multiple projects. Running into quota limits during deployment can cause significant delays and require escalation to Google Cloud support. Certificate management strategy deserves special attention. For TLS inspection, you'll need a comprehensive certificate authority setup that can generate certificates for all domains your users access. This often involves integrating with existing PKI infrastructure and ensuring client devices trust your CA certificates. Regional planning affects both performance and compliance. Choose regions based on user locations, data residency requirements, and regulatory constraints. Remember that some compliance frameworks require data processing to occur within specific geographic boundaries. API enablement and dependencies. Let's start with the foundation, enabling the APIs we need. The first command you see is G-Cloud Services Enable Network Security.googleapi.com. This command activates the Network Security API, which is the core service that manages all proxy-related operations including gateways, security policies, URL lists, and TLS inspection configurations. The second command G-Cloud Services Enable Compute.googleapi.com enables the Compute Engine API. You might wonder why we need this since we are not managing virtual machines directly. The reason is that the proxy service creates managed instance groups behind the scenes for scaling and resilience, and you need Compute Engine API permissions for network configuration, firewall rules, and routing table management. Next, G-Cloud Services Enable IAM.googleapi.com activates the Identity and Access Management API. This becomes crucial when implementing user-based policies and service account authentication. Without proper IAM API access, you cannot create the fine-grained access controls that make secure web proxy truly effective for enterprise deployments. The command G-Cloud Services Enable Cloud Resource Manager.googleapi.com enables project-level and organization-level policy management. This is important when you are implementing consistent security policies across multiple projects or when you need to inherit organizational security constraints. Finally, the verification command G-Cloud Services List enabled filter name network security and compute and IAM and Cloud Resource Manager format table name title state confirms all APIs are properly enabled. The enabled parameter filters to show only currently active APIs, excluding disabled services. The filter parameter uses Google Cloud Filter syntax within logic to match multiple service names simultaneously, and the format parameter structures the output as a readable table. API enablement typically takes 30 to 60 seconds, but propagation of permissions and quota allocation can take several minutes. Plan for this delay in your implementation timeline. An environment configuration strategy. Environment configuration is foundational. Get this wrong and you'll be debugging mysterious failures later. We start with export commands that establish our deployment context. The project ID choice is more critical than it appears. It must be globally unique across all Google Cloud customers and can never be changed after creation. Choose something descriptive that includes your organization name, environment type, and maybe the year. Region selection directly impacts both user experience and regulatory compliance. If your users are in Europe but you deploy in US Central 1, they'll experience unnecessary latency. More importantly, some compliance frameworks like GDPR require data processing to occur within specific geographic boundaries. The region also affects which advanced features are available. Newer services often roll out to certain regions first. The zone setting affects where supporting infrastructure gets deployed. While the proxy service itself is regional for high availability, some supporting resources like managed instance groups need zone-specific configuration. Choose zones with strong historical uptime records. You can check this in the Google Cloud status page. Now, the gcloud config commands are where we make these settings persistent. The project config command stores your default project in the local gcloud configuration file, which persists across terminal sessions and even system reboots. This prevents the common mistake of accidentally deploying resources to the wrong project. I've seen people accidentally deploy production resources to development projects because they forgot to set this. The region and zone config commands work similarly, establishing persistent defaults that apply to all subsequent commands. This reduces parameter repetition and ensures consistent resource placement. The format parameter in the verification command creates a structured table showing section, property, and value. This gives you a complete audit trail of your configuration state before deployment begins. The echo commands might seem trivial, but they create a deployment summary with timestamp that's invaluable for documentation and troubleshooting. When something goes wrong weeks later, you'll appreciate having this deployment context recorded. Security policy architecture. Now we build the security framework that will govern all web traffic. The policy creation command establishes our main security container. This policy acts as a rule engine that evaluates every single web request against an ordered list of conditions and actions. The location parameter makes this a regional resource, which affects both latency and data residency. Policy evaluation happens in the region where the policy is stored. The description parameter is required and serves multiple purposes. It's used for operational documentation, change tracking, and compliance audits. Many organizations have policies requiring detailed descriptions for security controls, so make this meaningful and specific. The URL list creation command is particularly powerful. The values parameter accepts comma-separated domains and supports wildcard patterns like *malicious.com. What's really valuable is that this list can be updated independently without modifying individual security rules, crucial for rapid threat response. The list supports thousands of entries and regular expressions, making it suitable for enterprise-scale threat management. The security rule creation commands introduce the critical concept of priority-based evaluation. The priority parameter is key here. Lower numbers mean higher priority and earlier evaluation. This rule has priority 100, so it's evaluated first. Rule evaluation stops at the first match, so you want your most specific and frequently matched rules to have lower priority numbers for both security and performance reasons. The matcher parameter comes in two flavors: URL lists for simple domain matching, and expressions for complex logic. The action parameter determines what happens when a rule matches. Deny immediately blocks the request and can serve a custom block page, while allow permits the traffic to continue. The business application allow list demonstrates matcher expressions, which support complex Boolean logic. You can combine host matching with user identity, time of day, source network, request headers, and content types. The priority of 200 means this is evaluated after critical security blocks but before general rules, ensuring that business-critical applications remain accessible even if broader category rules might block them. Gateway security deep configuration. Gateway security operates at the connection level, before individual requests are even processed. The gateway policy creation command includes a crucial parameter, TLS inspection enabled. This activates man-in-the-middle certificate generation, allowing the proxy to decrypt and inspect HTTPS traffic. This is enormously powerful, but requires careful legal and technical consideration. The certificate authority pool creation uses several important parameters. The location parameter ensures the CA operates in the same region as your proxy for performance. The tier parameter set to enterprise provides enhanced security features, compliance certifications, and higher availability SLAs compared to the standard tier. The subject parameter defines the CA's distinguished name, This appears in certificates and should reflect your organization's identity. The max chain length parameter is a security control that limits how deep certificate hierarchies can go. Setting this to 3 prevents attackers from creating overly complex certificate chains that might confuse validation logic. The issuance policy parameter, if specified, controls which types of certificates the CA can automatically issue, crucial for preventing unauthorized certificate generation. The TLS inspection policy configuration includes several security-focused parameters. The CA pool parameter links to our dedicated certificate authority. This must be correctly configured, or TLS inspection will fail. The exclude public CA set parameter is particularly important. It prevents automatic trust of public certificate authorities, reducing the attack surface by requiring explicit trust relationships. The custom CA pool parameter explicitly defines which certificate authorities we trust for validation. This creates a more secure environment by limiting the trusted certificate sources. In enterprise environments, you typically want to trust only your organization's CAs, plus a small set of well-known public CAs. The advanced security rule demonstrates session and application matchers. The session matcher evaluates connection-level properties like TLS version, cipher suites, and certificate characteristics. The application matcher analyzes application layer protocols and behaviors. Both matchers must evaluate to true for the rule to activate. This in logic enables sophisticated security policies that consider multiple factors simultaneously. Core gateway deployment. Creating the proxy gateway is where all our preparation comes together. The gateway creation command has several critical parameters. The type parameter set to secure web gateway is crucial. It enables HTTP/HTTPS specific optimizations, content inspection capabilities, and web security features. Other gateway types like Secure Web Gateway Internal or API Gateway have different capabilities and limitations. The ports parameter defines which network ports the gateway listens on. Each configured port increases resource utilization and potentially attack surface, so only configure ports you actually need. Port 80 handles HTTP traffic. 443 handles HTTPS, and non-standard ports like 8080 or 8443 might be needed for specific enterprise applications that use alternative ports. The scope parameter is an organizational tool that becomes critical in large deployments. You might create different scopes for different user populations, for example corporate employees, contractors, partners, or different geographic regions. Scopes help organize policies and make management more tractable when you have hundreds of rules across multiple user groups. The certificate URLs parameter supports multiple certificates for different SNI requirements. You might need one certificate for your corporate domain, another wildcard certificate for subdomains, and perhaps a third for partner domains. The proxy automatically selects the appropriate certificate based on the client's SNI extension during TLS handshake. The addresses parameter provides static IP assignment, which is crucial for consistent client configuration. Without static IPs, your proxy addresses might change during maintenance or scaling events, breaking client configurations. Static IPs also simplify firewall route management and DNS configuration. The Gateway Update command demonstrates policy attachment. The Gateway Security Policy parameter links our carefully crafted security policy to the gateway for route enforcement. The Update Labels parameter adds metadata that is invaluable for resource organization, cost allocation, and compliance tracking. Labels can be used for automated billing reports, security compliance scans, and operational monitoring. The verification command uses YAML formatting with field selection to focus on operationally critical information. This structured output is perfect for automation scripts or documentation generation, and the field selection ensures you get only the information needed to confirm proper deployment. Network Infrastructure Deep Dive. Network configuration transforms our proxy from an isolated service into an active traffic processing component. The VPC creation command uses custom subnet mode. This provides complete control over IP addressing and network segmentation. Auto mode might seem easier, but custom mode is essential for enterprise deployments where you need predictable IP ranges and specific network topologies. The BGP routing mode parameter set to regional optimizes for single region deployments by keeping routing decisions local. This reduces latency and simplifies troubleshooting. If you're planning multi-region deployment later, you might choose global mode, but regional is more efficient for most proxy deployments. The subnet creation command includes several performance and security parameters. The range parameter, using /20, provides over 4,000 IP addresses. This is essential because the proxy service creates backend instances dynamically based on load, and these instances need IP addresses from your subnet. Plan for at least 10x your expected peak concurrent user count. The Enable Private IP Google Access parameter is crucial for security. It allows communication with Google APIs without requiring external IP addresses on proxy instances. This reduces attack surface and simplifies firewall configuration. The Enable Flow Logs parameter captures network traffic metadata essential for security analysis and troubleshooting. The flow logs sampling parameter is a performance optimization. 10% sampling provides sufficient data for analysis while minimizing storage costs and processing overhead. The metadata parameter set to include all provides comprehensive flow information including source, destination, protocols, ports, and packet counts. The firewall rule creation uses source ranges to restrict access to RFC 1918 private networks only. This is a critical security control. Allowing traffic from Quad 0/0 would permit access from anywhere on the Internet. The target tags parameter provides specific targeting, ensuring firewall rules apply only to resources with the correct tags. The Enable Logging parameter is essential for security analysis and compliance auditing. The routing command is the critical piece that actually directs traffic through our proxy. The destination range of Quad 0/0 captures all Internet-bound traffic. This is a powerful configuration that affects every outbound connection from the VPC. The Next Hop Gateway parameter directs this traffic through our security gateway before external forwarding. The Priority parameter ensures this route takes precedence over default routes that might bypass the proxy. Identity and Access Management. Authentication and authorization configuration ensures security throughout the proxy service lifecycle. The Service Account Creation command establishes a dedicated identity for proxy operations. The Display Name parameter provides human-readable identification crucial for audit trails and administrative tasks. The Description parameter documents the account's purpose, which is essential for security reviews and compliance audits. The IAM policy binding commands implement least privilege access. The member parameter specifically identifies our service account using the full email format. The role parameter grants exactly the permissions needed for proxy traffic processing. No more, no less. The gateway user role includes permissions for policy evaluation, traffic forwarding, and security inspection, but excludes administrative functions like policy modification. The condition parameter is a powerful security enhancement that implements time-limited access with automatic expiration. The expression uses CEL, Common Expression Language, to define complex access conditions based on request time, resource attributes, or environmental factors. This prevents abandoned service accounts from accumulating permissions over time. The logging and monitoring role assignments use separate policy bindings for granular control. The log writer role enables comprehensive audit trail creation, while the metric writer role allows custom metrics publication for monitoring dashboards. This separation follows security best practices by granting only the minimum permissions required for each function. The identity-aware proxy configuration adds an additional authentication layer for user access. The OAuth brand creation establishes your organization's identity in the authentication flow. The application title parameter appears in user consent screens, while the support email parameter provides a contact point for authentication issues. The project parameter ensures the brand is created in the correct project context. The OAuth client creation uses a dynamic brand reference through command substitution. The format parameter with value output extracts just the brand name without additional formatting, while the head command selects the first result if multiple brands exist. This approach ensures robust automation even in complex environments with multiple identity configurations. Comprehensive observability framework. Logging and monitoring create the operational intelligence foundation for your security program. The BigQuery dataset creation establishes our analytics platform. The location parameter ensures data residency compliance by storing security data in the same region as the proxy operations. The default table expiration parameter implements automated data lifecycle management. 90 days provides sufficient retention for most security investigations while controlling storage costs. The labels parameter adds crucial metadata for data governance. Purpose, compliance, and environment labels enable automated data classification, cost allocation, and access control policies. Many organizations require specific labeling schemes for security data to ensure proper handling and retention. The audit log sync creation uses sophisticated filtering to capture only relevant security events. The log filter parameter combines service name matching with method name filtering to focus on configuration changing operations. This reduces noise while ensuring complete coverage of security relevant activities. The include children parameter captures logs from nested resources and related operations, providing comprehensive audit coverage. The use partitioned tables parameter is crucial for performance and cost optimization. BigQuery partitioned tables enable efficient querying of time series security data and can dramatically reduce query costs when analyzing historical trends or investigating security incidents. The security events sync uses different filtering criteria optimized for operational monitoring. The resource type filter specifically targets proxy gateway operations, while the severity filter captures warnings, errors, and critical events. The security event type filter uses JSON payload matching to identify threat detection and policy violation events. The BigQuery retention opt-out parameter delegates retention management to dataset-level policies rather than sync-specific settings. This provides more flexible retention management and ensures consistent data lifecycle policies across all security data. The monitoring dashboard creation uses JSON configuration for programmatic deployment. The time series query configuration filters on network security gateway resources and custom metrics. The alignment period parameter provides 5-minute aggregation windows suitable for real-time monitoring, while the series aligner parameter calculates threat detection rates for trend analysis. Validation and testing methodology. Testing validates that our complex configuration actually works as intended. The gateway describe command focuses verification on essential operational status. The format parameter with table output provides clean, readable status information without overwhelming detail. The field selection extracts just name, type, and state, the critical information needed to confirm operational readiness. The connectivity testing uses curl with specific parameters designed for proxy validation. The proxy parameter directs traffic through our gateway at the specified IP and port. This tests the complete traffic routing path from client through proxy to destination. The header parameter adds a custom identifier that appears in logs, making test traffic easily distinguishable during analysis. The verbose parameter provides detailed connection information including DNS resolution, connection establishment, TLS handshake details, and HTTP transaction timing. This information is invaluable for diagnosing connectivity issues or performance problems. Security policy testing uses controlled attempts to access blocked domains. The max time parameter prevents the command from hanging indefinitely if the proxy correctly blocks the request. A properly configured proxy should either fail this request quickly or return a block page. Either response confirms that security policies are actively enforcing access controls. The log analysis command targets gateway resources specifically to focus on proxy operations. The limit parameter restricts output to recent entries for manageable analysis. The resource type filter excludes unrelated system logs that might clutter the analysis and make it difficult to identify proxy-specific events. These testing commands provide comprehensive validation covering 4 critical areas. Gateway operational status confirms the service is running. Traffic routing functionality verifies network configuration. Security policy enforcement validates rule effectiveness, and logging verification ensures audit trail completeness. Each test serves a specific purpose in confirming production readiness. Dynamic policy management. Policy management commands enable ongoing security operations as threats evolve and business requirements change. The policy update command demonstrates version control integration. The description parameter documents policy changes for audit trails and rollback procedures. The update labels parameter with version information enables automated change tracking and policy lifecycle management. URL list management uses the add values parameter to append new threats without disrupting existing entries. This is crucial for rapid threat response. You can immediately block newly discovered malicious domains without risking the removal of existing protections. The command supports bulk operations, so you can add multiple domains in a single operation. The conditional access rule creation showcases sophisticated business logic implementation. The priority parameter positions this rule appropriately in the evaluation sequence. The matcher expression parameter uses Boolean logic combining host pattern matching with time-based restrictions. The host function identifies Facebook traffic using regex patterns, while the time function restricts access to specific hours. Geographic control rules demonstrate location-based access restrictions. The matcher expression parameter evaluates the geographic origin of requests using the geo.country function. This enables compliance with data sovereignty requirements or restricts access based on geopolitical considerations. The action parameter set to deny blocks traffic from non-authorized locations. These policy management examples demonstrate the platform's flexibility for implementing complex business rules. The matcher expression syntax supports combining multiple conditions with and, or, and not operators, enabling sophisticated policies that consider user identity, device compliance, geographic location, time restrictions, and content characteristics simultaneously. Operational Excellence Framework. Operational excellence builds on the commands we have learned but focuses on processes and procedures rather than individual technical steps. Continuous policy evolution uses the URL list update commands we demonstrated, but implements them through automated systems. The add values parameter becomes part of scheduled jobs that integrate threat intelligence feeds, updating block lists without human intervention. Zero Trust implementation combines multiple policy rule commands with increasingly sophisticated matcher expressions. You might start with simple domain-based rules, then add user group restrictions, then device compliance requirements, and finally risk scoring based on behavioral analysis. Each enhancement uses the same command structure but with more complex expression logic. Privacy-compliant TLS inspection requires careful configuration of the TLS inspection policies we created earlier. The exclude public CA set parameter we discussed becomes part of a broader privacy protection strategy. You might exclude certain traffic categories from inspection, implement data handling procedures for inspected content, or provide user notification about inspection policies. Incident response integration leverages the logging syncs we configured to feed SIEM systems through BigQuery exports. The BigQuery opt-out retention parameter enables flexible data retention policies that support both operational monitoring and compliance requirements. Automated response workflows use the same logging read commands we demonstrated for testing, but triggered automatically by monitoring alerts. Performance optimization involves regularly analyzing rule evaluation order using the sort by priority parameter. Frequently matched rules should be moved to lower priority numbers for better performance. The list command with priority sorting helps identify optimization opportunities and ensures efficient policy evaluation. Advanced troubleshooting and future growth. Troubleshooting commands focus on extracting specific diagnostic information efficiently. The gateway describe command with value formatting extracts only essential status information without formatting overhead. This makes it perfect for automated health checks or scripted monitoring where you need just the facts without decorative output. The compute instance creation for debugging uses carefully chosen parameters for cost efficiency and diagnostic effectiveness. The machine type parameter set to E2 micro provides the smallest possible instance for cost control. The network parameter places the debugging instance in our proxy network for accurate connectivity testing from the same network context as the proxy service. Policy analysis commands use table formatting to create structured views of security decisions. The format parameter with timestamp and action fields shows when requests were processed and what enforcement actions were taken. This makes it easy to trace policy evaluation and identify patterns in allow/block decisions. Rule conflict detection uses the sort by priority parameter to show rule evaluation order. This visualization makes it easy to spot conflicts where rules might never be reached due to earlier matches, or where rule ordering creates unintended policy behavior. The CSV format enables spreadsheet analysis for complex policy optimization. Future growth strategies build on these same foundational commands with expanded scope and sophistication. Multi-region deployment involves running the same gateway creation commands across multiple regions with region-specific parameters. Advanced DLP integration uses enhanced policy rule commands with more sophisticated matcher expressions for custom data classification and protection. The key insight is that mastering these G-Cloud commands with their various parameters and options provides a complete toolkit for any enterprise proxy scenario. Whether you're doing initial deployment, ongoing operations, performance optimization, or complex troubleshooting, you'll use these same commands with different parameter combinations and contexts.